Hey there, everybody. Welcome to the Daily Space Weather. Check out the closest star. We've got SDO footage is back. We've got some coronal mass ejections to cover, some new sunspots, some issues with the solar cycle that you may be interested in. We're nowhere near solar maximum. This is composite imagery from SDO. Colorized magnetogram plus 171 angstroms. A conflagration of sunspots in the southwest massively raises the likelihood of solar flares. Here's your colorized magnetogram, and let's show the intensitygram. Check out the high latitude sunspots down here. Also a new sunspot over here. We'll get to the names of those a little later in the video. Let's do a volcano rundown quickly. On the Kamchatka Peninsula, we've got Karimsky exploding. That's an uptick at Karimsky, flight level 200. It's a 20,000 foot ash plume. Also on the Kamchatka Peninsula, Shivaluch exploding, flight level 150 at Shivaluch. Subanosejima, flight level 070. Krakatoa, now back on the list, 8,000 foot ash plume from Krakatoa. Nevado del Ruiz, 21,000 foot ash plume over Colombia from Nevado del Ruiz as it explodes. Sangay in Ecuador exploding, flight level 210, and we're unable to detect whether or not Sabancaya is erupting. Please do not assume that it isn't and pole vault the caldera. Shout out to Erica Palmerio. Erica Palmerio, one of our accounts that we follow on Twitter, posting a great CME. We'll talk about that momentarily. Follow us on Twitter at twitter.com/smashomash. Yes, we're aware of the pathetic censorship on big tech sites. I would remind you that big tech cannot break the internet, however the internet can break big tech. So it's been pretty calm as far as earthquakes over earthquakes over the past 90 days. It has been pretty calm, yeah? Only 2 7 magnitude quakes over the past 90 days, and things have been pretty chill over the past 24 hours also. A few quakes there around Indonesia there, north of Australia. It looks like we haven't even seen a quake in the 5 magnitude range here over the past 24, so very calm. Not a large number of quakes, and no large quakes over the past 24 hours. Remember, folks, if you're in an earthquake-prone zone, we would like you to be an asset, not a liability, in the event of a disaster. Know which building facades may collapse, have a bug-out bag, have a battery backup, etc. Check it out, we got a comet. There's a comet diving into the sun here. And it's not all the way there yet. Anyway, that's some imagery of that CME that we showed earlier. We do not expect that to be Earth-directed or have an Earth-directed component. Here's a closer view of that. Some great imagery there from the Soho Lasco C3 and Soho Lasco C2. Radio flux is now at 114 solar flux units, so an increase in the radio flux. Also a large increase in the likelihood of solar flares. We'll get to that in a bit. There's the 1-year graph of the radio flux. It's this black line. And you can expect this to rise higher and higher as solar cycle 25 progresses. And NOAA forecasting a little bit of geomagnetic unrest late in the day on August 8th. That must be the coronal hole high-speed stream. We've got a very well-defined coronal hole right around the solar equator. We'll get to that momentarily. Here's Earth's magnetic moment from space for the past 4 hours. It's a geomagnetically calm situation at the moment. Magnetohydrodynamic pressure kind of low for the past 4 hours. And indeed the past couple of days, following the subsiding of a rather weak coronal hole wind stream. Here's Earth's magnetic moment from the ground. Magnetic flux density around the surface, not real high. No real surprises there to our regular viewers. We show the footage daily. Again, that's the last 4 hours, Earth's magnetic moment from the ground. Magnetic flux density. KP index at 1. Geomagnetically chill conditions. And let's take a look at the real-time solar wind here. Minor uptick here in the past few hours, but solar wind here about 7.6 protons per cubic centimeter. Solar wind speed dropping and dropping down to 347 kilometers per second. Looking at magnetic data, here is the GOES 16 and GOES 17 magnetometer readings. Some arcjet moments there as they adjust their orbits using their thrusters, creating plasma, and informing you that the readings might be off. And indeed, it looks like they were off. Right around here, you can see a drop there. They must have gotten some plasma around their magnetometers. Next, the heliospheric current sheet. Earth is in a North Pole current sheet. If you're wondering if the Milky Way galaxy has one like the Sun's, it's got nothing of the sort, especially tens of thousands of light years away from the galactic core. Here is the line of sight field plot. We've got a bunch of North Pole magnetism facing the Earth at the moment. Let's move to coronal holes next. Here you can see those North Pole oriented coronal holes there shown in green. Next we'll show those in 193 angstroms. And that well-defined coronal hole there, quite visible in this wavelength. Let's get that off the screen. It's too much flashing. All right, so we've got a new sunspot, sunspot 3073. So 3 sunspots here in the southwestern limb, and a new sunspot over here on the eastern limb. I would also note how far south sunspot 3073 is, another indication that we are nowhere near solar maximum. And let's continue on to show some imagery from SDO. This is the Sdo Continuum Imagery. And we'll zoom in, since all the activity is in the southern hemisphere. So quite a few sunspots there. The sunspot number will rise way up here, and the likelihood of solar flares getting much higher as those sunspots approach the limb. So we may see some major flaring here. That's a lot of sunspots. They are magnetically complex. They are beta-gamma class sunspot groups. This one's also beta-gamma class. We've got some trailing umbrae there. This one's also beta-gamma class. It looks like we've got a second umbra there. So all of these things make the likelihood of solar flares a little bit higher. Most likely place to see major flares is indeed in the southwest. So there's that array of sunspots, and I would again note how high of a latitude this group is, indicating that we're just still sort of at the beginning stages of solar cycle 25, nowhere near solar maximum. And as these set, the likelihood of major flares much higher. And we're going to continue on to show things like the X-ray flux. First, I would invite you to install the Twitch mobile app. It'll actually inform you when we go live, unlike some streaming platforms. Take a moment to press like and subscribe on YouTube. Leave us a comment. Thanks to all of our viewers over the years, we've been making space weather videos, the most in-depth space weather videos, the most comprehensive in the world over the past about 5 years. If you want to support the channel, consider becoming a gold or silver member of the Smash Team at smashomash.com/SmashTeam. It's our own subscription services site. If you're not seeing all of our videos in your subscription feed, click on Posts. from smashamash.com/smashteam. You'll see all of our videos. We put up some swap videos yesterday because of some SDO data lack. Also some new links on smashamash.com and smashamash.com/smashteam that we'll get to in a moment. First, our featured merch of the day is Do Not Pole Vault the Caldera. No matter how bad things seem, if you're going through hell, keep going. Our finest days lie ahead. So don't pole vault the caldera. It could be unhealthful. We don't want you to become part of a lava lake, and we don't want to inhale you. You might smell good. You don't smell that good, so don't pole vault the caldera. No matter how good your field team is, it's unwise. You may be planning a trip to Iceland. Leave your vault pole at home. Smashamash.com will provide you the link to our Redbubble shop. You can also find it below this video. And we've got a new link at smashamash.com, so welcome to the Neo Renaissance. We're interested in improving your health, yes. Not just improving your online experience. We're interested in actually improving your health. Did you know I'm a licensed Medicare insurance agent? Yeah, it's true, folks. I'm actually licensed in 21 states. And check out our new link. Shout out to Smash staff to our SureMed page. So if you'd like to beef up your health coverage, great features here at SureMed. Click the link below the video or on our homepage at smashamash.com. It's worth the $20 a month for the base membership level just for the teledoc service. You can also talk to a shrink on the phone, get all kinds of discounts. You can do a virtual veterinarian. They'll even call in your prescriptions for you, folks. It's splentacular. All kinds of discounts, retail and mail order pharmacy. Health Advocate Solutions includes a medical bill payer feature where they can save you some cash on your medical bills, perhaps. So again, visit the links, and let's get back to the realm of X-rays. Yes. So again, the likelihood of X-rays getting much higher here as a result, especially those sunspots on the western limb. As all of those set, don't be surprised to see some major flares, an M or possibly even an X-class flare. We're going to see the X-ray profile rising here over the next couple of days. So let's bring up the latest imagery here from SDO. There's the 94 angstroms wavelength. That's one of the wavelengths to view if we do see X-rays. Solar flares. Don't get them confused, folks. Solar flares are photons. Coronal mass ejections are protons. We don't see any relativistic protons at the moment. We might see some especially if we see major flares. At the moment, still flatlined on the proton flux. And we encourage you to go up. If you go up before dawn, you may see Saturn, Jupiter, Mars, and Venus ahead of the sun there on the ecliptic. That's the yellow line we've drawn in. This star chart is from in-the-sky.org. Here's your solar system forecast. This is where things are now. Keep in mind, this is not to scale, and we'll advance this 1 week. And there's where things will be in a week. We will have a gibbous waning moon by then. Looks like full moon will be on the 12th of August. And here's some more coronagraph imagery for you. This is from George Mason University. That's yesterday's images, and we'll also show you today's. So there's yesterday, and here's today. You can see that coronal mass ejection we showed earlier. We'll also show you the view available from Stereo A and from the Soho Lasco C3. Again, not an earthly directed coronal mass ejection. And we do have a comet also showing up here on the Soho Lasco C3. You'll see it down here in the southwestern quadrant. Right there. Little bit of a probably suicidal comet there. making its way toward the sun. Next, hydrogen alpha imagery, and we've got quite a lot of filaments at the moment. Check out these filaments down here. These are very likely to eject. These pretty likely to eject as well. We're seeing quite a bit of activity here in the southern hemisphere. That's your hydrogen alpha imagery from El Teide, Spain. Even some filaments in the northern hemisphere. And remember, folks, we don't need solar flares or sunspots to see coronal mass ejections. We were showing them regularly and even forecasting them around solar minimum. Next, the GOES 16 SUVI, and we got this great prominence down here. That's why we're zoomed in. Part of that collapsing, part of that likely ejecting as well. And let's zoom out to show the whole view. There's ionized helium from the GOES 16 SUVI. Going to bring up some more imagery here. The 171 angstroms wavelength from Sdo. And let's continue on to our bonus features segment. So satellites community dashboard, not showing any charging hazards. Things are looking safe for satellites at the moment. GOES electron flux here kind of at low levels. Again, we are expecting a cratering of this when the coronal hole high-speed stream shows up in about 2.5 days. Here's the forecast model. Again, we can expect this to be actually way down here. Hey there, we're expecting this to be way down here, not way up here, when the coronal hole high-speed stream arrives. And it could be a significant one. I would expect to see, I would agree with Noah, geomagnetic unrest at least, maybe even a brief geomagnetic storm period. It all depends on the magnetic fields. There's the 1-year chart of the relativistic electrons. We'll show the F-ionosphere layer also. So here's your ionogram, courtesy Australian Government Bureau of Meteorology. And here's your anomalygram. And some low-frequency anomalies here around the South Pole. Quite a bit of red showing up there. Some large swings from low to high-frequency anomaly over Central Africa, as we've been seeing for a few days. And here's the latest image, 10 o'clock Universal Time. Next, your total electron content forecast. It's going to show you the free electrons. And when your GPS satellite must communicate through a lot of free electrons, you get a refracted signal. People around the equator are aware their GPSs will not work well around noontime. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. So just for your new viewers out there, to show you what we're talking about, it's the area in between your GPS satellite and your handset. If this signal is going through the inner Van Allen belt, you're going to have a refracted signal, and your GPS is likely to be off by thousands of miles. So turn on your Wi-Fi accuracy if you're seeing high electron contents above your head. It will increase the probability you'll be able to navigate to wherever you want to go. This is a plasmasphere. This is a plasmasphere. There's plasma constrained in there by the outer Van Allen belt or the inner Van Allen belt, indeed both if it's the outer plasmasphere, and below that is the ionosphere layer. This satellite, your GPS satellite, is located at about 12,500 miles of altitude. And let's bring up the latest intensitygram to reiterate the fact that there are a huge number of sunspots down here in the southwest. And the likelihood of major flares goes way up as a result of those sunspot groups. Here's your colorized magnetogram, and they're quite magnetically complex. Let me try that again. There are the magnetic fields, and again, lots of separate magnetic fields there. You can see both polarities. Those are all beta-gamma class sunspot groups. And we got a new sunspot in the north as well, so check it out. There's another group that's going to get named. There's another sunspot group. That'll be 3075, assuming no others form. But I'm pretty sure that's 3075. And I think that may be also beta class. Pretty sure I see a second umbra there of South Pole orientation, so huge conflagration in sunspots. Let's bring up one more series of images. How about this composite series of images from Sdo? 2 species of ionized iron and 1 of ionized helium. 211, 171, and 304 angstroms. Yowzers. And hey, thanks for tuning into the most detailed imagery of the sun and the most comprehensive space weather on the entire internet. I think it's about time. It's about time to move to the realm of meteorology. Yes. Yes, I realized weather forecasting was too easy. That's why I went out into the realm of space weather. And we're looking at Saharan dust here. This is the DUX, which is showing 550 nanometer aerosol particles. And this low pressure system is being weakened by all of that dust. It has a tendency to shut down convection. Large anticyclone here in the eastern Atlantic. You can see that clockwise rotation happening. And let's switch to the surface winds. Here are the surface winds of the eastern world. Here are the jet streams of the eastern world. Quite a chaotic jet stream here in the northeast. A little bit more concentrated jets with more massive cold air in the southeast. Here are the jet streams of the Americas. We've got a continuing anticyclone here over the central U.S. You can see that clockwise rotation there. And it's creating a bunch of convective systems down here in the southeast, which is less than optimal for places like Kentucky. We'll get to it. Here are the surface winds of the Americas. Here are the surface winds of Europe, Africa, and the Middle East. And here are the jet streams that covers the whole planet. Backward jet stream continues over the northern Indian Ocean and northern Africa. Your weather.gov map showing continued flooding here in West Virginia, southern Ohio, and eastern Kentucky. Again, less than optimal. We'll show the forecasts. Also some flooding forecasted here for Nevada. Some weather advisories there in Alaska as well. If your county is lit, head to weather.gov and click your county. A little bit too many counties to cover. Let's move on. Here's our total accumulated precipitation forecast. And you can see another inch or two of rain expected for places like eastern Kentucky. Again, less than optimal. That's a GFS model for the next 72 hours, total accumulated precipitation. Here's your pressure and precipitation forecast. Again, the GFS model over the next 72 hours. It should be pretty accurate for you. And it looks like this loitering low here is going to be moving up to Baja California area. perhaps creating some beach erosion. And speaking of waves, the biggest waves in the world right now are in the southern Indian Ocean. 27 footers down there. It's a pretty desolate portion of the world, though. Not a lot of people there to experience those waves. One of the many features of windy.com is wave height. We've got some similarly sized waves here in the southern Pacific. Next, looking at lightning. And we're into August, but the lightning is continuing. That's what's been going on over the past about 10 hours, and we'll go to a real-time lightning map next from lightningmaps.org. And do we have some terrestrial strikes? Indeed we do. It looks like the hottest cell here is west of St. Paul, near Brookings. And it looks like there's some thunder rolling in at Hutchinson. And there's your global real-time lightning map. Keep in mind there are not lightning sensors on the whole world, but the part that has them, that's where the strikes are currently occurring. Next, your radar.weather.gov Doppler radar map. And we'll also show clouds and fog via the 3.9 nanometer radiation satellite. That's infrared radiation at 3.9 nanometers. It shows clouds and fog. It's too dark over half the country to use the visible satellite. And here is the water vapor satellite. Again, this low is sort of unable to really get a lot of convection going. It is surrounded by Saharan dust, which does not help to strengthen a weather system. Clear skies over central Florida at the moment. And this moisture up here is actually getting constrained by butting into this high pressure system here. Unable to move to the south. It's kind of stuck there. And here's your recap. US Doppler radar. Shortwave radiation showing clouds and fog. And there's your water vapor map. When in doubt, because your Doppler is not helping you to understand where your weather systems will move to and so on, check your Doppler. Thanks for tuning in. Thanks for leaving a comment, John of Life Force Rejuvenation. Sup! We'll see you soon at the Smash News Network, least busted name in news, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.